Good morning. Hi. How are you today? I'm good. Hi.
Morning, everybody. It is Tuesday, December 15th, and this is In Case You Missed Psychology. If you're watching this, that means you couldn't get to class today, and that's okay. I hope you're well. I hope those around you are well, and I hope I hope you find some time to do something you like to do today. I don't know, read a book, play a video game, listen to some music, write. I don't know, whatever your jam is, do that. All right. I definitely was listening to some music before I did this. So don't want to waste a ton of your time today. I want to get straight to the point, talk about the things we talked about in class. If you are keeping up with us in the Dream Project, which, God, I hope you are. If you're not, message me. We'll figure out how to get you caught up. Today's topic, I got a little card that I keep them on. Today's topic is, first of all, it's 12:15. It is journal number 9. We're almost done. And today's topic is largest problem. So label the top of your paper. If you want to write right now, set your little stopwatch for 8 minutes. And the longer version is, aside from COVID, what's the biggest problem that you're facing in your life right now, and how do you think you're going to solve it? There you go. If you don't have one that you can write about for 8 minutes, you can write about a couple. They don't have to be big doozies, but try to be honest and write about that biggest thing you got going on right now, and what do you think your solutions are? So 8 minutes on that one. If you're going to write right now, pause the video, write for 8 minutes, and then come back and finish up. Otherwise, get it done later. If you're missing any of the topics, if you're like, Seep, I don't know what number blah, blah, blah was, please feel free to reach out to a classmate first and then hit me up. I don't always have them in the perfect order, but obviously I can find them out. I can talk to Kate if I need to. Other than that, the reminders for today, keep up writing the dreams down. If you're having dreams, get those ideas down. And don't forget about those outside of class journals. We've only got one journal left to write. We'll do that tomorrow. And then we are done with the in-class part of things, other than me being annoying with reminders. Oh, you have some work due today. The lobes of the brain, the 10 multiple choice questions that go along with the short reading that I wrote up are due today by midnight, so make sure you get those done. And I guess if you owe me any late work, go ahead and get that done too. So today what we're going to do is we're going to look at a part of the brain called the cerebrum and the cerebral cortex. And then we're going to look a little bit at the hemispheres and what they do. If we have any time left at the end, or if you have any time left after we get done with this, do some work, try and get some stuff done. And again, as always, if you have any questions, I'm here. You just got to ask, okay? And that goes for not just homework, but, heck, if you're struggling on something in another class and you think I can help you, please reach out. That's what I'm here for. Okay, so we're going to hit ahead on the first slide here. And what we're going to look at today is the cerebrum, or the cerebral cortex. And as you can see, Squidward is taking his brain out of his head. In the case of Squidward, the pink part that you can see on the outside, the actual, what you guys would probably describe as the brain, is the cerebrum. Okay, the outside chunk that's probably about, I think it's like 8 to 10 millimeters, so not very big. That's the cerebral cortex. Okay, we'll talk about that a little bit separately, but we're going to look at that outside part of the brain first. And honestly, it's probably the most recognizable part of the brain, because when we see them on TV and movies, whether it be a cop medical show or it's a zombie movie, the cerebrum is probably the part that we're seeing. If you've ever done anything with one in anatomy or ever gone to a cadaver lab, I know we haven't had many field trips in the last chunk of time, you have probably seen the cerebral cortex in the cerebrum of the brain. This is where all your higher level functioning goes on. And when I say higher level, not your life support things. This is where storage is. This is where visual and verbal information is interpreted. This is where math and science, this is where school stuff lives. This is where how to drive a car lives. It's where art ability lives. It's where voluntary movement lives. It's where, that smells good, it lives. Okay. And so it's really kind of what makes you is in the cerebrum and the cerebral cortex. A lot of that is in that outside layer, which is referred to as the cerebral cortex. Now, I'll throw you a few physical things about it and a few other little pieces before we go into the hemispheres. Generally speaking, the larger a species, now not an individual because we're all pretty much the same, the larger a species cerebrum is, the more likely it's going to be able to adapt and change its behavior when needed. And so I always like to use this example, and I'm sorry, I probably wasn't the best little kid in the world. Okay, let's say we're going to go on a field trip. So we could get together. We're going to go on a field trip. We're going to go to the Y, and we're going to go swimming. Your reward. We're going to spend a morning swimming. It's going to be 85 degrees in the pool room, and we're going to go swimming at the Y in Sun Prairie. Now, let's say you can't swim, and I decide I'm going to teach you. I'm going to teach you how to swim the old school way. Okay, what that means is I'm going to take you to the deep end, and I'm going to go, hey, you can. I'm going to put my arm around you. I'm going to go, hey, you can do this. It's just, if you don't like putting your face in the water, don't put your face in the water. It's one arm over, kick your feet, breathe, whatever, and I just shove you into the 12-footer. Okay. Now you might freak out, and you're going to doggy paddle, and you're going to get back to the side. But if you come to the ladder and I just push you right back in, I would think you're smart enough. I would hope you're smart enough, and I would hope you could tread water well enough that you would go to a part of the pool to get out next where I'm not there. Okay, you're going to try to avoid me. When I was a little kid, sorry, again, I swear to God, I turned out more normal than this. We used to catch garden snakes by my house, and we would take them down to the lake across the street, and we would swing them and throw them in the water. And the snakes would swim right back to us, and we'd throw them in again, and they'd swim right back to us, and they'd throw them in again, and they'd swim right back to us. And eventually the snake didn't come back. Well, that's not the ability to adapt. That's not what they do. A lot of animals are pattern-based animals, and you'll find it's a lot of like what are considered to be not as smart animals are pattern-based animals, and you're going to find that those animals don't have much cerebral cortex. We're going to talk later when we talk about the lobes of the brain about how much of your brain is cerebral cortex and how much each part is and things like that. But suffice it to say, humans have the largest percentage of cerebral cortex and cerebrum of any species that we know of on this planet. Okay. And so we are more likely to adapt. Now, some visuals. If I could bone saw it out and plop it down in front of you, what would you see? First thing is, it basically is going to resemble a giant walnut. It's got those cracks and those wrinkles, and some of the wrinkles are deeper than others, and we'll get into what those are called in the next slide. But it's very much going to have that physical look like a walnut itself. If we could, you see wrinkles, and it looks like it's intertwined between itself. If we could unwind it, and we can't, it's not like a ball of yarn. It's very brittle. It's very easily broken, very easily damaged. But if we could unwind those curves or those wrinkles and line it up, it would be about half an inch wide, but it would be about 5 feet tall. So I don't know, if I was standing up, you guys get a general idea. We'll come to somewhere between my chin and my mouth, somewhere in that ballpark. Okay. And so if you can unwind it, you have about 5 feet of material, about half an inch thick inside your head. And that's just the cerebrum and the cortex. That's not the lower brain structures that we're going to talk about on, today's Tuesday, Wednesday, Thursday. Okay. If you could see one as is in someone's head, the outside layer is going to be mostly gray, but then you would see black, white, and red. The black is going to be different cells, different materials, some of the neurons going through the blood cells, or blood cells. Ugh. The veins and arteries are primarily going to be the other things that you're going to see. But the truly the pink that you see in cartoons, that's not what you're going to see. And the color that you've seen, where it's almost like a yellowy color on like shows, that's a brain that's been preserved. It's been put in something. That is not what a brain looks like. Okay. All right. Next one is about the hemispheres. And I think you're probably aware that your brain is broken into hemispheres, that there is a right hemisphere. I'm doing this off mine, so if it's not right on your side, please understand that I know what I'm doing here. All right, there's a line that goes down the middle of your head, almost like if you parted your hair down the center, and there's a right hemisphere and there's a left hemisphere, and the two are marked off by a depression. So a hemisphere is one half of the cerebrum. There's a lot of different things that have hemispheres, but in this case, we're talking about the brain. So it's one half of the cerebrum and one half of the cerebral cortex. Okay. One of the really important things to note, and some people were struggling this with a little bit on the homework, my right side of my brain controls the left side of my body. And so if I'm waving, I'm getting a little bit ahead of myself here, talking about something we're going to talk about tomorrow. But if I'm waving my left hand at you guys, hi, good morning, hi, the right motor cortex is what is doing that. And vice versa, obviously, the left side of my brain operates my right hand and my right leg and all those different things. And so the right hemisphere controls the left hemisphere controls the right. There is obviously a place where the nerves kind of cross over. There are these things in your brain and are called fissures. Fissures are deeper depressions, deeper wrinkles, lines, whatever word you want to use for them. Any of them work. That mark off separations between parts of the brain. They're also sometimes, instead of called fissures, they're called sulcuses. The one that travels down the middle, which is one of the deeper ones, is called the longitudinal sulcus or the longitudinal fissure. Okay. Now, the two sides of the brain, obviously, they operate separate sides of the body, but the two sides of the brain have to be able to work together. And so about a couple inches down inside, it would actually be, if I took my fingers and went like this, draw a line, there you go. And actually you can see here in green, the part that I'm talking about, that's called the corpus callosum. Corpus callosum, I've heard it said both ways. We're not going to have a pronunciation test. You can talk to Miss Bent about that. I don't know if she still does those pronunciation things. But it's a bundle of nerves that allow the two hemispheres to communicate back and forth to each other. It's kind of like, we don't use them as much anymore because everything is Bluetooth, but it would be like the cable line that goes from your wall and hooks into your TV. If you still have one of those, it allows the cable to talk to the TV so that you can play whatever shows or whatever you're doing. Now, sometimes people have to have their corpus callosums cut, or they get cut on accident. Obviously, you can see based on where this is, if this gets cut by an accident, you're probably not living. But there are people that have. I read something about somebody that had like a piece of glass, like impalement, go in there and cut this thing. It's also a very popular place for, unfortunately, for tumors to grow, and so they've had to go in and get those out. And sometimes in people that have really, really bad seizures, grand mal seizures. I don't know what you guys know about seizures, but grand mal seizures, they've actually found cutting the corpus callosum again. Tomato. Cutting the corpus callosum can actually stop those seizures, or at least slow them down. Now, what we found in people that have a cut corpus callosum where the two sides can't directly communicate is there are definitely some things where we see delays. People with cut corpus callosums generally can do everything you and I can do, but if they're doing something that requires right side activity and left side activity, there might be a delay. Now, it's not like the right hand's going to move up to catch a ball and then at 30 seconds later their left hand's going to come up. Those kind of things are going to work because my right eye controls. I think you guys understand what I'm saying. But there's things like, for instance, story problems. Or math stories. I don't know what you guys called them when you were in school. But where I'm reading a problem, Billy walked into the store. He bought 2 apples. He walked over and bought 2 peaches. And then he bought 4 bananas. How many pieces of fruit did Billy buy? I mean, that's not hard. It's 8. God, I hope I added that up right in my head as I was doing it. The answer is 8. If I didn't, call me out and I will send you something. I don't know. But you have to put together verbal information and mathematical information, which aren't both housed directly on the same side of the brain. And so you might see a delay in trying to put those together. The kid with a cut corpus callosum is still going to be able to say 8. He's still going to know it's 8 pieces of fruit. And so it's just going to be a delay. I've heard things like people with cut corpus callosums can't drive cars or heavy machinery or different things like that. I would assume that's possibly true. Now, one other thing about the hemispheres is the hemispheres have different tasks that they specialize in, kind of different things that you tend to see out of people. Now, a lot of people have dominance on one side over the other, a side of the brain that seems to control more things than others. Don't automatically make the assumption that because you're right-handed, I'm right-handed, I write with my right hand, I throw with my right hand, I kick with my right foot, I do all the stuff with my right hand. Don't think that I'm automatically left-brained. That might mean I'm left brain dominant for my motor cortex, but that doesn't mean that the way that I think or the things that I'm good at are that way. So I'm going to show you something that sometimes we do to pick this out. I'm going to go into presentation mode, so I'm going to disappear for a second because I want to show you guys this video. It's not very long. If you want to, you can watch it multiple times. I'm only going to show it once here.
Hi, here's a dancer. She's clearly spinning in one direction. Or is she? It's been said that if you see her going counterclockwise, you use more of your left brain. On the other hand, if you see her going clockwise, you use more of your right brain. Most of us see her turning in one direction, but you can use all your brain power and make her spin the other way. Try it. If you start doing math, will it go counterclockwise? And if you think about something creative, will it turn clockwise? That actually happened to me. The simple brain test reveals some very interesting things. For example, my friends and I all saw the dancers spin in the same direction, and only after we trained ourselves were we able to make it spin the other way. So maybe birds of a feather flock together? Do we subconsciously seek those whose personalities are most similar to ours? Or in your case, if your friends differ from you, maybe opposites attract? Then, there's that nature versus nurture debate. How much does our brain dominance influence our hobbies, and vice versa? So, is it really that simple? Are you only right or left-brained? Of course not. In order to function most effectively, both sides should work at the same time. But we still have our dominant tendencies. Here's my challenge to you. Let me know if you're right.
All right, we're
Or
for
left
2
brain.
seconds. There we go. Pause. Now, I'm going to just talk over the thing, and then I'll come back to you guys. When some people watch it, she spins in the same direction the entire time. Like, for instance, the first few times I watch it, she spins in the clockwise fashion almost the entire time. After watching it a couple times, I got to the point where when the animation slows down, nothing about the animation ever changes other than the speed at which she is spinning. Okay. But after a while, when she slowed down, I could get her to switch where she spun counterclockwise. Now, I've seen this enough times that I can switch her. Here, I'll come back to you guys now. That I can switch her kind of whenever I want to. I can get her going like this. Now, we found when we're in class, we usually watch this 2 or 3 times. We watch it together. We watch it a couple times, and we kind of see how things look. Now, as we're going through this, if you want to watch it more than once, please just pull back. You're going to get mad if you can't get her to switch. I'll tell you that right now. It's okay. It's not like you're stupid or anything like that. You'll have people that have like these aha moments where they can get her to switch. Now, the last slide we're going to look at today has to do with this. And this is basically, if we were in class, we would take a brain dominance survey to tell whether or not you're right or left brain. You can find them all over the internet. If you want to take one, it'll probably take 5 minutes. And then if you want to come back to this slide, you can. But this slide deals with brain lateralization or brain dominance. And this is the skills that seem to be more housed in one hemisphere than the other. Now, I'm not going to read through the list. I'm going to invite you to pause this quickly and think about, like, what are you good at? And if there's words here like you don't get, like, for instance, detail-oriented perception versus holistic perception. Detail-oriented people tend to see the little pieces, and holistic people see the whole. They see the whole before they see the parts. Detail-oriented see the parts before they see the whole. Okay. Any of the other stuff I think is relatively self-explanatory. When I take a brain dominance survey, I come up predominantly right-brained. Now, that's really kind of got to be it for today. But I do encourage you to, 1, make sure you write the journal for today. 2, make sure your homework is done before midnight tonight, that lobes of the brain. 3, if you want to go back and watch the ballerina again, watch the ballerina again. There's different versions on YouTube, but that's kind of one of the cleaner copies as far as, like, I think the verbal that goes along with it helps. And last but not least, if you have a few minutes, take a brain dominance inventory. See if you come up right-brained, left-brained, or even balanced. There's some people that really tend to be balanced. And then come back and look at this slide and see where you score out. Okay. If you have any questions, please let me know. I'm more than happy to help. Hope you're well. Please reach out if you need me. Have a great day. Bye-bye.